Good day, everyone. So this video is about my project audio classification using deep learning. So I have used Urban Sounds 8K dataset, which is available in Kaggle. Let me show you the dataset. So this is the dataset Urban Sounds 8K. So basically this dataset contains 10 folders ranging from with the data sets of 7 GB with the CSV file which contains names of the files and everything, like what class it belongs to, everything. So basically this is the information about the advanced on data set. So I have used this data set because it has 10 classes: air conditioner, car horn, children playing, etc. So they have arranged the folder in order to they have shuffled the class files into these folders randomly, but with at the same time they have done it with the highest precision in order we can get a high accuracy in the TensorFlow runs. So this is the dataset I have used, and I have published my Kaggle notebook here also. So in order to understand the GitHub project, you first go through this Kaggle notebook. So basically, if you go through the Kaggle notebook, you can understand. But even though I'll just I'll just give a brief overview. So first we are importing the required libraries. So Librosa given is used for audio classification. It is used to extract audio data from the WAV file. So rest of all are the as usual data libraries: sklearn, sklearn, and the TensorFlow library. And I've used log calls to record the accuracy of the models, which I will show you after. So this is where we read the data. So I have set the audio data path as input from since Kaggle uses // input in order to access their Kaggle dataset. So I have used it also. I have just changed the class labels from this from air conditioner. They have it contains underscore values, so it won't be need for any newcomers coming. So I have changed it to air conditioner with which is kind of neat. So that's it. So this I have got the CSV file from the dataset, and it's stored in the metadata data frame. So this the data frame contains 10 classes, as you can see, and so in order to view how many files, number of audio files per category, so I have just used a matplotlib library to show it. And MFCC is the mel frequency coefficient. So this MFCC is a differentiating feature which separates the audios. Like air conditioner has some MFCC, so and the car horns has different MFCC. You can see the color is different, and also their values is different. Same for children playing, etc. So for 10 classes, I have just given a visualization for MFCC data. So this is where the main part comes: feature extraction, database building. So I have given the also. So what it will do is, since we can't since TensorFlow accepts only text data, I have used Librosa library to extract the features from metadata, which is basically features from the audio from the audio file using MFCC, and with also MFCC is an inbuilt function within Librosa, so which will extract the features from the audio file and it will store it in the variables, and this loop will run for approximately 15 minutes based on your system. So Kaggle notebook took 15 minutes to run this file. So it will run for each file. So this data frame contains 8732 rows, so it has ran for that many times. So it is stored in the list. This list looks like this. I have converted the list into a data frame. So basically a dog box has these categories, so these features basically I have extracted the feature and stored it in the data frame. So in order to differentiate dog bark and child playing, these are the features, these are the numbers which differentiates it. If you have gone through the CNN model, not the CNN image classification, so what we will do by doing is we will classifying the image data to text data. So same thing we are doing it for audio also. Just I'm using label encoder, and I'm preparing the data frame and separating it to a list. So that list will be given in the TensorFlow. So y is equal to 2 categorical, which will the y contains the class array, which is this. So I see I have given here. So y contains the class array, which will categorize the list. Since for dog bark 1, children playing 2, similarly for 10 classes. So this will split the data set. And so first model I have used is basic ANN model. So these are the layers, and I just constructed the model. So these are the details about the layer, and I am compiling the model with the Adam optimizer, and I am fitting the model. So this model will be saved as model1.h5, so which will be later used in the Django project, which will show I shall show in few minutes. So this is how the model will be fitted, and it will be saved. And I forgot to show you something. So this extractor feature will be saved to a pickle. If you don't know what is pickle, just search in Google. It will show that it basically Python way of saying a CSV file. So it if you are using if you know data science, we can extract the data frame into CSV. Same way, two pickle will be used to extract all the data, like from the data frame. So I have used it for extracted df pickle file in the my Django project also. That's why wherever I am using output file, these output file will be used in the my Django project. So the ANN model will be like this. Is the ANN model. This ANN model will be saved externally, and this will be used in my Django project. So basically this is I have ran it for 250 epochs. So it has ran. So these are the results: loss per epochs, accuracy per epochs, and yes. So this is a basic function, ANN prediction function. When I just pass the path of the wave file which I am going to predict, which will basically give me the predictor class. I have already wrote the code. If you want to understand the code, just read it for yourself. And so just testing the model with the sample audio. I don't know if you can hear it. Yes, this is the dog box. So I've just tested it with the audio. So basically what it does is the ANN function will get only ANN function has certain type of input. TensorFlow model has a certain type of input. Wait, I will show you. So this is the thing. First layer, which is this one, input shape. So this input shape, ANN model has a input shape to 128. If we give just the extractor features to this ANN model, it won't give the output. So we have to give in such a way that we have to process the extract. Just we have to first give the file name. We have to load the file name, audio file, and we have to get the feature which is stored in the feature variable, and we have to scale the feature, and we are storing it the array of features into NP array, and this NP array is will give the predictor vector, and we are using here the ANN model dot predict. This will predict basically the model dot predict will get the input which feature we are going to build, and it will output the output the vector, and this output is given in the label encoder. It will inverse transform it, and it will give the predictor class. So it will be giving 10 class. We are taking the first class because first class contains basically the first accurate result. So it has been done for CNN 1D. Same thing. You can see the layers. I don't want to explain it. You'll know. And same thing. I have just storing the model 2, and even for model 2 I have written model 2 I have written a wait a minute, I'll show you here. So this is the model 2 also I have written a prediction function which will be useful for the Django project. I'll show you. So this is the model 3 also. So after running all the scripts, so I have storing the log calls data frame for comparative analysis. So basically I have done the comparative analysis between the three models, ANN, CNN 1D, CNN 2D. So this is a model accuracy, model training time, model prediction time. So this is the overview of this notebook and this project also. So if you want to know other things, just search YouTube, like audio classification using Krishnaik. I saw his video and I have done the project. So basically he has done 4 parts. You will get better overview, better understanding if you watch his videos. So my way of explanation is maybe it's not good, but his explanation is very good. So just go and watch him. So coming to this project, so this is the project. In order to access my project, just to download it, and I just download the project and extract it somewhere. So this is where I extracted it. I extracted in the desktop. So this is the extracted folder. So if you are new to this thing, just type in. We have to first install the virtual environment. So in order to create a virtual environment, this is the command python 3 dash venv. This is the name of the audio environment, environment name. So I have already created it, so I don't want to create it. If you want to create, just create it. And yes, so that I am using for different things. So this is basically the project. So in order to activate the project, just to go to so this is the project folder. Just type audio venv /bin/activate. So this will activate the virtual environment. So whatever you type pip install will basically install all these things, all the things in the virtual environment. So the necessary packages for this project is this notebook. Notebook is basically the Jupyter notebook, Librosa, Pandas, Seaborn, NumPy, TQDM, Matplot library, scikit-learn, TensorFlow, obviously Django. So and we also need Keras utilities. I don't think we need to. So these are the things we needed. So just type, go to that CD to that project, give source audio venv/activate. so it will activate it, and just type pip install -r requirements.x. It will automatically install all the packages which is needed into the virtual environment. I have already done it, so don't do it. I am not doing it, so you go and do it. And let's get into the project. I'm using Visual Studio Code. If you don't know what is a Visual Studio Code, just go to the site VS Code. So this is Visual Studio Code. It is open source course code editor. Just select the operating system which you are in. It is available for Mac OS, Windows, Linux. So I'm using Linux. I download it and I set up my account. So if you are new to this project, just type let me run the project, Python. So in order to run the Python's Django project, just type this command. No, these are not errors. These are the TensorFlow warnings. So basically I'm using CPU to run the TensorFlow. If you have CUDA cores, like if you have NVIDIA GPU, you won't get these errors. So what it is saying is I could not load dynamic library because I don't have a CUDA core. So no worries, just go to this site and select so basically yes, Urbans on AK. Go to any file, folder file, first file, let's select it, submit. You can see even the terminal also. So this is the terminal. So it has predicted that this thing is street music. You can also see it here. So let me check it. Urban Sounds 8K, folder 6. So what is the file name? S65. I think it's belong to folder 4. Just search it, 6508 in the file 9090101. Yes, this file. You may not clearly hear it. Basically this is a street music. Let me go to another. Let's select another file. Opens on 8K. Let's take first one. Gunshot. So it belongs to gunshot. Let me hear it. I don't know if you can't hear it, but this is a gunshot sound. Yes, so it has accurately predicted that it belongs to gunshot. So this is my project. So I'll show you how this project works. Let me stop the server. So let me go to the VS Code. So if you want to edit some files, so basically this is the virtual environment audio NV. I have created an assets folder. So this, let me zoom in. So this extracted df.pickle is the pickle I have said earlier, which contain the data frame, which contains the extracted features. You have to run it. You don't have to run it each and every time to get the extracted features. So basically model 1.h5 is the TensorFlow model. Model 2 also TensorFlow model. Model 3 has Tensor model. I am using it here in the functions.py. So this is the main Python file. So basically I am creating the storing the pickle file into a data frame, and I am again using the label encoder to get the features. So I am loading the models in the using the load model which is present in the TensorFlow keras model. So I have declared created 4 function. So this extract feature function is common for all the models. So what this the ANN prediction function will get the extracted feature from here, and it will get the give the input to the ANN model, and it will predict the predict class 0. Same for CNN only, same for CNN 2D. So this is how it predicts the this is how the my project works. So you can just download it. You can also if you are running it on your own, just to change if you change these files, you are good to go. That's it. So these are this is the ways. This is a demo of my project. So thank you.